Question number 12. Phenol on oxidation with chromic acid gives benzene, benzaldehyde, quinol, benzoquinol. So phenol on oxidation with chromic acid. Chromic acid is formed by Na2Cr2O7 in presence of H2SO4. Sodium chromate in presence of H2SO4 that produces chromic acid, that is H2Cr O4. So this is an oxidizing agent. So phenol on oxidation gives benzoquinone. So this is the structure and this is called a benzoquinone. So option D is the correct answer for question number 12. Then question number 13. On oxidation, an alcohol gave a product X which reduced tolerance reagent. Which of the following could be the alcohol? Oxidation of alcohol gave a product X. So if X reduced tolerance reagent, this X should be an aldehyde. So that is the point. So we get X here, that if it reduced tolerance reagent, that should be an aldehyde. So let's check which alcohol gives this aldehyde. Normally primary alcohol on oxidation gives aldehyde. Primary alcohol on oxidation gives aldehyde. So on oxidation of an alcohol gave a product X. So let's check whether the alcohol gives an aldehyde on oxidation. That alcohol should be X and that reduces tolerance reagent. So here 3 alcohols are given. P is CH3, CH2, CH2OH. So this is a primary alcohol. So this will give an aldehyde on oxidation since it is a primary alcohol. So Q is CH3, CH2, CHOH, CH3. So this is a secondary alcohol that will not give an aldehyde. Actually this gives ketone. So this will not give an aldehyde. So in the case of R, this is a tertiary alcohol. So this is a tertiary alcohol. Actually this resists oxidation. So P, that is the alcohol which is primary in nature, that gives aldehyde on oxidation. So option P, that is option A, only P is the answer. So option A is the correct answer. Then question number 14. This is an example of CH2 double bond, CH single bond, C, CH3, CH3, OH. So this is an alcohol which is an example of vinylic alcohol, primary allylic alcohol, secondary allylic alcohol, tertiary allylic alcohol. Here OH is connected to this carbon, which is again connected to a double bonded carbon. So this carbon is allylic in nature. This is allylic in nature. So this is an allylic alcohol. And now let's check whether it is primary, secondary or tertiary. So OH is connected to this carbon. This carbon is directly connected to 1, 2 and 3 carbon atoms. So this is tertiary also. So tertiary allylic alcohol. So this compound is an example of tertiary allylic alcohol. So option D is the correct answer. Then question number 15. The IUPAC name of the compound CH3, CH, CH3, OCH3. So O is the functional group. So this is an ether. So ether is named as alkoxy alkane, and alkoxy part should be the smaller part and alkane part, that is a parent chain. So that should be the longest part. So let's find out the alkoxy part. So this part is the alkoxy part which is smaller in nature. So this is actually methoxy, since there is only one carbon here. So this is methoxy group. And the next side, the other side is CH3, CH, CH3. So that is the alkane part, or it is a parent chain. So let's number this chain, that is 1, 2 and 3. So 3 carbon atoms are there. In the second position, this is the methoxy group. So that can be considered as a substituent, and this is the longest part, and this can be considered as the parent chain. So alkoxy alkane, that is the format. So this is methoxy, 3 carbon atoms are there in the parent chain. So it is methoxy propane. So methoxy group is actually in the second position. So 2-methoxy propane. 2-methoxy propane is the answer. So option C. Let's see next question, that is 16. What would be the major product of the given reaction? So HCHO. HCHO is formaldehyde or methanol. reacts with CH3MgI, that is Grignard reagent, alkyl magnesium halide. Here it is methyl magnesium iodide. So there is an addition product. Addition product is formed at first, that is OMgI and CS3. So this is the adduct formed at first. Then which on hydrolysis H plus H2O, which on hydrolysis give H will be attached here and OH will be attached here. So this will break and the compound will be formed like this. So this is CH3. So this is CH3 CH2OH, CH3 CH2OH, plus there is a byproduct, that is MgI OH. So this is the main product and this is nothing but ethanol. So methanol gives ethanol as the final product. So option C is the correct answer, option C. Let's see the next question, that is question number 17. Which statement is or are correct about methanol? Methanol is poisonous, colorless liquid with specific smell. Even small quantity intake may cause blindness. All of this. So actually all these 3 points are correct. So all of this, option D is the answer. So this is all these points are correct for or correct about methanol. So all of this is the answer. Then question number 18. The heating of phenyl methyl ether with HI produces iodobenzene, phenol, benzene, ethyl chloride. So C6H5O CH3 plus HI, phenyl methyl ether, or we can draw like this. So here this bond will not broken since there is resonance. So in this case this bond will break. So the main product will be, so H will be attached here and I will be attached here. So phenol is the main product. So phenol is the main product. So option B is the correct answer. Then question number 19. Major products formed by heating CH3 thrice CO CH2 CH3. CH3 thrice CO CH2 CH3. So HI, addition with HI, heating with HI. So in this case, one possibility is H will be attached here and I will be attached here. That means if this bond is broken, H can be attached here and I can be attached here. So the other possibility is with this tertiary group, I will be attached and H will be attached with this group. So 2 possibilities are there. So let's see. This is the first possibility. Then second possibility is with the tertiary group I will be attached, with the other group OH will be attached. So these are the 2 possibilities, but in this case this is the correct answer, or this will be the products formed, since in this case we can see a tertiary group. So we know that tertiary carbocation is more stable. Tertiary carbocation is more stable. So due to the stability of tertiary carbocation in the case of this halide, so this will be the final products. So stability of tertiary carbocation causes this product formation. So this is the answer, or these are the products formed, and here option A. So option A is the correct answer for question number 19.